Hello everyone once again. Now we are still continuing with the drawing and determining of the equation of the parabola. Remember that previously what we looked at the case whereby we were given the equation and we were asked to draw the graph. And then now we're looking at the different case. We could be given the equation and we are asked to determine what the graph is and what the equation of the graph is, right? So there's various cases for this. The first case, we'll look at three cases specifically, but the first case that we'll look at the case whereby we are given, bear in mind this is not the equation of the turning point, it's just a random point that lies on this graph, and we are given two roots, right? So this is the case whereby we are given roots a, alpha and beta. This is just a variable saying that it could be any roots, and we're given another point. So we need to use this in order to determine the equation. I'll demonstrate shortly how you use that. So for instance, and this makes sense because I'm not sure if you remember, our equation is written in the form of a x squared plus bx plus c. You could have factorized this and you'd get the roots. So now we are given two roots and another point. Two roots and another point. How you do that? You need to use that equation. A x minus alpha x minus beta. This is just to say these are random roots, right? But here we know what roots are. Roots are basically the values of x that give the graph equals 0. So we see that y equals 0 at these points, and the coordinates here, right? If we write this in terms of coordinates, it's minus 3 and 0, and here the coordinates are 1 and 0, right? So we have three coordinates, our roots, which are, I'll just write them neat here, minus 3 and 0, and we have 1 and 0. And then we have a random point, which is minus 2 and this is minus 6. So this is what we have, and we are asked to determine the equation. So we said when given such a case, and it's important to be able to note, and I want you to note that it's not going to be as easy as it is on the example to note what case to use. You need to be able to, the only way you'll be able to note what it is by repetitive practice, seeing what you need and understanding of the equation. So let's do this. What you need to do is you say a x, right, minus the first root. The root is minus 3, right? X minus the second root is 1. So this is what you do. So you have this now, a x plus 3 x minus 1. This is what you have. You have y equals this, right? And the next thing that you do is you use your given coordinate to determine, because you notice now we have this thing right already, but the only thing we need is to determine what this y value, this a value is. And if we're able to determine that, we should be able now to distribute this and write the equation in a form of ax squared plus bx plus c, right? So now let's do this. We have here on the random point, our y value is minus 6 equals a. Our x value is minus 2, then plus 3. X is minus 2, minus 1, right? And if you simplify this, you have minus 6 a and 1 times minus 3, and then we have sorry, it's not visible, minus 6 equals minus 3a, which is a equals 2. So you can just solve for a equals 2, and then the next thing is you go back to that and you say y equals 2 x plus 3. So we've already substituted plus 3 x minus 1. So we have this equation now. We can distribute, and if we distribute this, let's just help you with the. If you distribute this, basically you'll just try to distribute. You'll get an answer of 2x squared plus 4x minus 6. This is the answer you'll get. So notice now, this is now written in the form of ax squared plus bx plus c. So this is how you, this is the first case. So I'll demonstrate on the next video the second case that we can encounter in these problems.